Many people were astonished by this lecture from Professor Walter Lewin of the MIT, where he presents the gyroscopic effect. First, he attaches the wheel to a rope on one end of its axis. When he lets go, of course the wheel flips over. Then, he spins the wheel and attaches it the same way. Magically, when he lets go, the wheel doesn't flip, but stays perfectly vertical. Also, it slowly spins around the rope. Then, he attaches a weight to the other end of its axis, which does still not flip the wheel over, but, even more counterintuitively, accelerates its rotation around the rope. So, what's happening here? Is this black magic? Is the wheel possessed and requires professional exorcism? In this video, we'll explore this phenomenon in a very direct approach. No formulas, no physics gibberish, just you, me, plain English and drawings. Imagine the wheel has many narrow angular segments, like pieces of a pizza. When the wheel is not rotating and you hang it on a rope in a vertical position, it flips. Why? Because the segment which is on top is moving left and down, the segment which is on the bottom is moving right and up. Hence, there is a flip. Now, spin it. The segment which is on top in a given moment is, as before, starting to move left and down, but a fraction of a second later it has rotated to the bottom. Its motion gets flipped on its head, which would mean left and up. But on the bottom it wants to move right and up. When it is about to do that, it's on top again. In other words, if the wheel spins fast enough, the acceleration of each segment changes direction so quickly that the segment doesn't flip in any direction at all. Hence, no segment is able to flip over, and consequently the wheel doesn't flip. In physics, this phenomenon is summarized by the term mass moment of inertia, and is the reason why the rotation axis of any quickly rotating body is stable. Okay, easy enough. But why does the wheel as a whole rotate around the rope? Let's take another look at our wheel. When on top, the segment wants to move left and down, on the bottom it wants to move right and up. During the time our segment spends at the top half of the wheel, it is in fact beginning to flip towards the left. So a fraction of a second later, when it reaches the flipping axis, it's slightly removed in that same direction. This then happens in reverse on the other side. From the top, this effect looks like this. Another way to describe this is that when the wheel is turning, it is still flipping over, just that the flipping which is happening has been turned by a 90-degree angle. In fact, every outside force which is applied on the spinning wheel perpendicular to the axis is turned by 90 degrees for that same reason. Therefore, when Professor Lewin hangs a weight on the wheel, it just increases the rate of rotation that has originally been caused by gravitation, pulling on the axis of the wheel in the same direction. Also, when we change the direction of the spin, the 90-degree flipping of all those forces being applied on the axis is flipping as well.